Okay, everyone, it's been a long haul, but here's the last slide for this unit, 12.6, surface area and volume of spheres. So spheres are a little special. We put them all, surface area and volume, in one section. So let's look at the definitions here. A sphere is going to be the set of all points in a space, 3D space, equidistant from a given point. And that given point is right here in the center. That's your center point. Okay? A radius is going to be a segment that will go from the center out here to the edge of the sphere, to any point on the sphere. That's your radius. A chord is a segment whose endpoints are on the sphere. So if you look over here on this one, there's a chord right here with endpoints that are on the sphere. Okay, don't go through the center. They're not a radius. It's just a chord. It's a little piece that goes through the center. Or not the center, but on the inside of your sphere. Now, a diameter is the chord that contains the center. So it goes from side to side, and it goes right through the middle of the center. Sorry, let's go back to this one for a minute. I didn't get that surface area of a sphere in here. So here's your surface area. Surface area is going to be 4 pi r squared. Now remember that area is a squared unit. So that's where we get the pi r squared. 4 pi r squared. Remember pi r squared, that's our circle, right? Well, we've got a bigger area here. So 4 pi r squared. So let's find the surface area of the sphere. 4 pi r squared, so the surface area equals 4 pi, my radius, which is 8, squared. Okay, and so for exact terms, exact value, we'd want to do the 8 squared times the 4, which would be 256, and we'd leave the pi there. That is in terms of pi, exact value. It's an area. Area is a squared unit, inches squared. So if I want approximation or decimal, if it says to round to, you're going to type in 256 times pi, and I would get 804.25. And again, that's inches squared. All right, let's look at this example 2. The surface area of a sphere is 182.25 pi. Notice that the pi is right there. Square centimeters, and we want the diameter. So we've got a little bit of a multi-step problem here. Let's go back and remember the surface area is 4 pi r squared, and we have the surface area. So we're going to plug in what we know, and I'm going to start over here on this side. 182.25 pi. Don't forget that pi. 182. Just didn't want to write. 182.25 pi is the surface area. So that's what goes in here for S. Equals 4 pi and then r squared. Now, we don't know the radius. It doesn't tell me that. So that's what I'm trying to solve for. I'm trying to solve for r. So we want to isolate that, get it by itself. That means I'm going to divide out 4 pi on both sides. And when I divide both sides by 4 pi, these pi's are going to cancel. Those will cancel. 182.25 divided by 4 is going to leave me with an r squared equal to 45.56. And then to get just 1r, we're going to take the square root of that 45.56. And when I take the square root, I'm going to get 6.75. Now, you have to ask yourself, have I answered the question yet? Because see what they're going to do, and this is going to happen on your tests. They're going to see that sometimes you're going to look and say, oh, look, there I have an answer. That's not what we want, though. That's my radius, and what was I looking for? I'm looking for the diameter. So I've got to do the radius times 2, which would give me a diameter of 13.5 centimeters. And so your choice here is C. Okay, we can look at, let's look at number 1 real quick here. The diameter of a sphere is 40 feet. Find the surface area of the sphere. Let's go up here and we'll write surface area again. 4 pi r squared. Diameter is 40 feet. Well, what part of that do we need? Half the diameter. So my radius is going to be 20 feet. So surface area equals 4 pi. Radius, however, is 20 feet squared. So in exact terms, my surface area equals 1600 pi, okay, or approximately, if we wanted decimals, if it said to round to 26.55, and this is in feet squared. Okay, surface area of a sphere is 30 pi square meters, and we want to find the radius. You know, in the previous slide we found one where we had to find the diameter. So we have done one that was just like this. We might save another example from off the worksheet on the in class. Alright, so now let's look at the intersection of a sphere and a plane. And we're going to look at volumes now in this slide. So when we intersect a sphere with a plane, and that's what this is, it's kind of a reddish color. It's like going a really thin slice right through the middle of that sphere. And that's called, what we would get would be this circle. And that's called the great circle. A plane that intersects a sphere that contains the center. So if that intersection goes right through the center, then that's when you get the great plane, the great circle. The hemispheres are what we get then when you cut a sphere in half. You get 2 congruent halves of a sphere separated by that great circle, and those are called hemispheres. Hemispheres. So let's look at the volume of a sphere formula. The volume of a sphere is 4/3 pi r cubed. Remember that volume is a cubed unit, so these are all going to be r cubed. So first quick example, the soccer ball has a diameter of 9 inches. Sorry, we're going to find its volume. Well, diameter is what I have, but I need radius. So the radius of this is 4.5. That's your radius. And my volume now is going to be 4/3 pi and my radius of 4.5 cubed. Okay? So 4/3 pi r cubed. Plug that all in. We're going to get about 381.7. Sorry, I left out the 3. Let's do this. 381.7 inches cubed. So remember to keep putting your units on that. Okay, I think we should go back look at something here for a second. If you look at the volume formula, let me change colors, and say I have a fraction here. A lot of people have trouble dealing with this 4/3. So let's look at this. 4/3 is a fraction. If I want to make the other two things a fraction, I can put them over 1. There I have a fraction, right? So I would have the 4 pi r cubed on the top, and the 3 would be in the denominator. So let's go look at what we would get in this problem if we kept it in terms of pi. I would get, on the top, I would have 4 times pi, and times that 9 cubed over 3. Does not want to draw 3's. Okay, so there's my 4/3 pi r cubed. And so if you were to calculate this to give me an exact value, you would end up with 486 pi inches cubed. And then that is an exact value, 486 pi inches cubed. So that would be your exact value. Okay, we're looking for the volume of a composite solid here. And so composite figures again. It tells us here to find the volume of the solid that we want. We're going to take the volume of the cylinder and subtract the hemisphere. So this is scooping out. It's like taking a scoop out of this cylinder. That's what we're doing. So we're taking out the volume of a hemisphere. So let's look at these volumes. Remember that the volume of a cylinder is pi r squared h. That's the volume, base times the height, and the base is a circle. And from that, I'm going to subtract the hemisphere, which is half of a circle, right? Or I'm sorry, half of a sphere. So I've got 1/2 of the formula for the sphere, 4/3 pi r cubed. So these are the formulas that I need. The volume of the cylinder, so pi, and my r is 2 squared times the height. And this one right here is the height. Remember, the height is in between the two bases. So times 2 minus, now let's do the 1/4 over 2/3. 1 times 4, I'll show you what I'm doing. I'm going to do 1 times 4 right here over 2 times 3, and that's going to give me 4 over 6. 4 over 6 is going to reduce to 2/3, and then pi, let's go back because I have an r, 2 cubed. Okay? So I'm going to get 2 squared here, which is 4 times 2, 8 pi, minus, this would be 2/3, and 2 cubed is 8 again, so this would be times 8 pi. So this will equal 8 pi. Now let's go ahead and keep this in terms of pi, and if I want to do that, I'm going to have to get a common denominator. So I'm going to have to make this term over here have a denominator of 3. So let's make that have a denominator of 3. If I put the 3 in the denominator, remember that I'd have to multiply the top by 3. And so that's going to be 24 over 3 pi minus, and 2 times 8 is 16 over 3 pi, or 16 pi, 24 pi over 3 minus 16 pi over 3, which is going to give me a value of 8/3 pi. And this is inches cubed. Okay, let's do number 5 on this one. We just did a problem where we left it in terms of pi. But let's do number 5 on this one, and we're going to leave this one, it says round to 2 decimal places. That's what we're going to do. A solid consists of a hemisphere with a radius of 1 meter on top of a cone with the same radius and a height. The cone has a height of 5 meters. So think about this. If I have a hemisphere, here's a hemisphere on top of a cone, and it kind of looks like an ice cream cone to me. So there's something to think about what it might look like. Here's our volume. The volume of the hemisphere and to the volume of the hemisphere, I'm going to add the volume of a cone. Okay, these are the pieces I'm looking for. And so my volume is going to be the volume of a hemisphere. Again, a hemisphere is half of a sphere. So I'm going to have 1/2, 4/3 pi, and then r cubed. Well, my radius is 1 cubed, plus the volume of a cone. Now the cone volume was, and that was from a previous slide, 1/3 pi times 1, which is the radius, squared, times the height of the cone, and the height was 5 meters. Okay? I hope you're all with me for right now. So, the first part here, again, like the last slide, I'm going to have 1 times 4 over 2 times 3. 4 over 6 is 2/3 pi, because this 1 cubed is just 1 still, plus 1 squared is still 1, times 5, which is going to give me 5/3 pi. And so if I add those together, I would get 7 over 3 pi, which is rounded in decimals, 7.33 meters cubed. And that is the end of our last slide.